though. So first of all, at the top, this even and odd, that's referring to the degree, which is the highest power. If the highest power is even, like 2, 4, 6, 8, then the arrows on the ends will go in the same direction. Okay, notice how for the even, they're both going up or both going down. Now, what determines if it's going to go up or down? What you need? What determines if it's going to go up or down is the first number in front of that first term. All right, so you will have to, so this is how we write it in Algebra 1 and Algebra 2, but in geometry, you have to express it as a limit. So what that means is, for this one, whenever it's even, you can write one limit. But you would say the limit as x approaches plus or minus infinity of f of x. And I could do plus and minus because it's the same. I don't have to differentiate between the right and the left for an even degree. So if it's an even and positive, then the left and right will approach positive infinity. So that's how you would write a limit for an even positive function. Now, if it's even and negative, you would still do the limit as x approaches positive or negative infinity of f of x equals, but because it's going down, what do you think I'm going to write this time? Negative infinity. Good. Now, the odd degree functions are the ones that tend to confuse students because they do opposite. And it's hard to figure out what side is going to go up and what side is going to go down, okay? What I need for you to understand is that the leading coefficient, it controls the right arrow. So that leading coefficient will tell you what it's going to do on the right. So if it's positive, if it's odd positive, that means that the right side will go up and the left side will do the opposite, which is go down. So let's express that as a limit. So I would say the limit, now I can't write one, I have to separate it because they're not doing the same thing. As x approaches negative infinity, and then I also have a limit as x approaches positive infinity. Now remember, the leading coefficient tells you what this is going to do. So if it's a positive leading coefficient, that means the right side is going to go up. And because it's odd, the left side is going to do the opposite, which should be what? Going down. And then we have the limit. Again, let's do this last one. This is odd with a negative leading coefficient. So we have the limit as x approaches negative infinity of f of x. So this is how you kind of have to practice writing a limit statement, because this is how you'll have to write it on the quiz. Oh, I did not mean to put negative infinity on both ones. Now again, the leading coefficient controls the right. So if it's a negative leading coefficient, the right side is going to now go down. So the right side, which is when x is positive, that's the right side of the y-axis, is going to go down. So I'm going to put a negative infinity for the right. And then the left side, because it's odd, will do the opposite, which means it's going towards positive infinity. So what I usually tell my students, in order to remember this, it's just really two things you have to remember. Remember, even degrees, they go in the same. And remember, odd degrees are opposite. So O. And remember that the leading coefficient controls the right. So if it's, that's it. Those three things, and then you should have in behavior. All right, so we're going to look at a few equations, and we're just going to answer a lot of questions about an equation. So let's go ahead and get started. So go ahead and just copy down one at a time, because I'm not sure how much space it'll take you. So just copy down number 1. And you can do some abbreviations. Usually I just put LC for leading coefficient, and I just put EB for in behavior. So from looking at the equation, without seeing a sketch or a graph, you should be able to tell me which of the 4 in behaviors, because there's only 4. There's just 4, okay? So number 1, is it an even or odd? So your highest exponent is 4, and this part doesn't matter. It's the leader of the train that determines everything. So it's a 4th degree, which is even, which tells me that the end behavior is the same. So I usually just abbreviate same EB. Now looking at that first number, you see how it starts off with a -1? So that tells me what? What is my arrow? They're going the same direction. So are they both going to go up or both go down? Go down. So you would write your limit. You would say the limit as x approaches positive and negative infinity of f of x is negative infinity. Now you could separate it and make it 2. But for even, I usually just, because they're doing the same thing, write it as 1. All right, go ahead and copy down equation 2 if you haven't already. Okay. Is this even or odd? What's the highest exponent? 3. Again, this doesn't matter. So this is an odd function, which tells me that the arrows or my end behavior will be opposite. Is the first number positive or negative? Positive 1. So I usually make a little sketch only for odd. Because it's positive, that tells me the right side will go up, which means the left side is going to do the opposite, which is go down. Left, right. So let's write our end behavior. So my left end behavior says the limit as x approaches negative infinity, because when I say left and right, I'm talking about the left side of the y-axis and the right side of the y-axis. So this is my left end behavior. And then I'm going to put R for right. The limit of f of x as x approaches positive infinity. So the left arrow, is the left arrow going up or down? Down. So we're going to put negative infinity here. And the right arrow is going up. Questions? All right. Okay. Let's do the same thing. We got 2 functions. Go ahead, copy them down, each one. Now we're going to answer a few more questions about it. The degree, the leading coefficient, the y-intercept, the constant, and the end behavior. You can mark the ones you missed. Next time, just use a highlighter, because I can't tell. Now, realize that these two are the same thing. The only difference is that when I'm asking for a y-intercept, your answer should always be an ordered pair. For the y-intercept, and if you, yeah, it should be an ordered pair. And the constant, or the place where the graph is going to cross through the y-axis, is always that one term that doesn't have an x. So in this one, and that's important because there's a few multiple choice questions on the quiz. In one, you have to identify the equation that matches the graph. The first thing you can do is identify where your y-intercept should be and eliminate some answer choices from there. So this graph has a y-intercept at 0, 1. And your constant is just 1. So I'm going to give you a moment. Since we've done this a couple times, I want you to try to answer these 3 by yourself. And when I say degree, leading coefficient, is it positive or negative? And then try to write your end behavior as a limit. All right, you can go ahead and check your answers against mine for A, and then try to fill in B all by yourself. Try to fill in every piece of information for this second equation by yourself, and then we'll come together and compare our answers. So for the first one, because it was a 4th degree, 4 is even, arrows are going in the same direction, which means I can write my end behavior as one statement. Because that was a positive 5, that's going to make both arrows go up. We already talked about that this at the end, that's your constant or your y-intercept. So now do the same thing for part B, and then we will come back together and compare notes. Y'all got through that pretty fast. All right, go ahead and check and see what you... So we have a 5th degree. The end behavior is negative. The constant at the end is 4, which means that's my y-intercept. The end behavior. So again, the leading coefficient controls the right, which is this one. So because that's negative, that means that the right side is going to go down. And because it's odd, the left side does the opposite. It goes up. All right, does this kind of ring a bell a little bit? This is what I'm teaching right now in Integrated 3, actually. So you've seen it. You may not remember it, but you've seen it. You did? Okay, you did. All right. Give everybody a chance to copy it down. So was it helpful, the videos that I made for the last, making the videos for the review? It was helpful? Okay, so I'm gonna work on trying to make some videos for the quiz review that I'm passing out next week. All right, so now let's talk about, now this is how the questions are asked in homework, on the homework. I'm gonna go ahead and just take off one. So just copy down example A, and then we'll do each one individually. So don't copy down these questions yet, just copy down the equation, and then we'll go through and answer each one of these questions one by one. All right, so the first thing we need to do is list each real zero and its multiplicity. So we have our first factor here, which is 3x. So this is part A. How many real zeros do we have? So real zeros, we set our factors equal to 0. So my first factor is 3x. My second factor is x plus 3. So when I solve the first one, that means that I have a 0 at x equals 0. Then my second one, when I solve it, that means I have a second one at x equals -3. Now, and it says multiplicity is saying what is the degree. So there's an invisible 1 right here. So for this first one, the multiplicity is 1. And for my second one, the multiplicity is 2. I'm going to abbreviate that. All right, so that's my answer to part A. Part B asks you to determine if it does a cross or a touch. So if your multiplicity or your degree is odd, it crosses. But if it's even, it touches. And we're going to do a little sketch in a second. So because at 0, 0, because that one had a degree of 1, that tells me at 0, 0 it's going to cross through. But at -3, 0, it just touches. Part C. What's the maximum number of terms? Well, first of all, to find our degree, we add up all of our multiplicity. So if I add them up, I have 1 plus 2, which means that this is a third degree function. So the arrows will go opposite directions. So the maximum number of terms that this graph can make is always whatever your degree is minus 1. So the max turns is 2. And then lastly, we're going to do our end behavior. So I have the limit as x approaches negative infinity of f of x. And then I also have the limit as x approaches positive infinity of f of x. So, does this have a positive or a negative leading coefficient? This number right here, we all agree is positive. So that means that the right side is going to go up. So this side is going to go up. So positive infinity. The other side is going to go down. Negative infinity. So when we talk about sketching a graph, this is what I'm just going to make a little sketch. You don't have to if you don't want to, but we determined that this graph had 2 ordered pairs. The one was at 0, 0, and then I'm going to say that, okay, this is my negative 3. So because, and then we also know the end behavior. So I know that from this last point is going to have to go down, and from this furthest to the right point, the arrow should go up. So the question is, what is it doing in between? So because the negative 3, because this is an even multiplicity, the graph is not going to go through it. It's just going to come up, hit that point, and then bounce back down. So the graph is going to come up, hit the negative 3, then it's going to bounce back down. Come down, make a U-turn somewhere, and then come back up and go through at the 0, 0. That's what that means. So I'm going to have you copy down the next one for tomorrow. We're going to answer these questions again. And then that is it for today. We're going to answer it tomorrow, not today. Let me see which one I want to do, though. I think I want to do D. So go ahead and copy down D for tomorrow. And we're going to answer all 4 questions again.